Hi everyone, welcome to the regression analysis lecture. For this session, we will continue our lesson on the all possible regression selection procedure. Previously, we've discussed about the R-squared criterion. Now we will be discussing about the adjusted R-squared or the MSE method. Okay, so as you can see from the formulation here, actually the adjusted R squared is just, some modification of the R squared. The question is that why do we need to do the modification of R squared? Actually, maybe this illustration can help you. This is from the previous one for the R squared. Okay, so let's say, okay, this is from our hypothetical data, what is it, the relationship between x and y, and then if we want to do the regression for the x and y, let's say I put it as fit 1, and it is just predicting y using x, and then let's ask for the summary. Okay, so here we get the result in here. Oopsie. So we got the result here that, okay, R squared here is 86.34%. Okay, means that the variability of y around 86.50%, 34% of it can be explained by x using the simple linear regression. Okay, because we only have one variable in here. Now, what's the problem with R squared? So that we need to consider other measurement, that is the adjusted R squared. That is because when we add more information, that is more x to the model, then the value of R squared will always increase, no matter how unimportant the variable is. Okay, so for example, let's just put, let's say I created another variable, let's say x2 is just, okay, from a normal distribution with the mean of, let's say, 10 and the variance of 6. Okay, and then if we want to plot between the x and y, okay, because here, remember, here I generated y, just I constructed y only from x and put some noise in here, so then it means that y does not have anything related to x2, and if I plot x2 and y is something like this, so no relationship at all actually, because again y is only constructed from x. Okay, no information from x2 in constructing y. Okay, but then if I for example, like, okay, I don't know about the condition, I just put whatever variable that I have x, I have x2, so I just put all of them in the model. So that's how I got it. Okay, so y from x and x2, in here we get that the R squared is increased to 87.34. Okay, you might be, if you just want to see the first model, if you want to compare it, fit 1, okay, that is just from x, the R squared is that, okay, I just write it here. R squared from the first model is that 0.8634, and then R adjusted squared is that 0.862. We have here 8634 And then from the second model, that is adding x2, that is not really significant, not don't really have any contribution. We have the r squared is that 0.87, just to compare here, fit 1, and then for fit 2 we have the r squared is that 0.8734. The adjusted r squared is 0.8708. Okay, so then there is an increment in the value of r squared when we add more explanatory variables to the model, although the variable does not have any relationship at all with the y. Okay, if we want to, let's just see if we add more variables. Let's say I add another variable, let's say x3, and then probably, okay, I just use again, yeah, it's alright, normal, and then like this. And then if we want to see x3 doesn't have any relationship at all with y, because again y is constructed only from x. Okay, so then if I have to run the regression, now I put x2 and x3 in the model in addition to just x1, then here we get the result. And then we got that the r squared here is that 8751, and then the r adjusted is that 8712. Okay, so in here we can see that what is it? No matter how we what is it? Every time we add explanatory variables to the model, then the r squared will be increased. Okay, we see here that the r adjusted is also increased, but not as much as the r squared. And then we can also see here, actually the good model is this one, right? This one is the good model. And then we can see here that one indication of our model is good or not is that the difference between the r squared and r adjusted is not that big. Okay, so here the difference is larger than the first one. Okay, so there's the problem with using just the r squared. We can always force it to uh, to be increased, that is by keep adding variables, while actually when you add more variables to your model, it means that your model becomes more complicated because more parameters to be estimated from the model. uh, and we know that there's a cost, actually if you want to increase the complexity of your model, then you also need actually to increase the sample size to make sure that the parameter estimation can be conducted properly. So that's why in R adjusted there is kind of like something here, there is a penalty. You want to increase, you cannot keep increasing the variable. If you want to increase the variable, then you also need to increase your sample size. Actually, that's the message that's given by the R adjusted. Because here, if you keep adding the complexity, if you keep adding the parameter, keep adding the variable means that adding the complexity of the model means more parameter to be estimated. Here is k is the number of variable explanatory variables 1. Here k plus 1 is actually because you have beta naught here. So here actually k is 3, but then we have another one here that is for the intercept, the beta naught. So that's why we have here k plus 1. Okay, if you keep adding variables but not adding your not increasing your sample size, then you know that at one time point it will be very, I mean that this ratio will close to 1, and then the R adjusted will be penalized, will be decreased. Okay, so it's kind of like a way of controlling the complexity of your model and the availability of your data. The main message is that don't just add any variables to your model just to increase the R squared, but just add some really important variables into your model. The interpretation of R adjusted is just the same with the R squared, but this measurement, the adjusted R squared, is much more reliable compared to the R squared, and that's why in a multiple regression model we prefer to use the adjusted R squared than the R squared. And for your task, I ask you to prove this formula. I mean that what we have in class is the first one here, and then now we have the second version of the formula for the adjusted R squared. So I ask you to prove that these two formulas are equivalent. Okay, thank you.